couple minutes here. But first I'll wait for some people to trickle in, join us, come hang out. While I'm waiting, I'm gonna go send the first video of the day to YouTube. Okay, that's going to YouTube. Young Lena, Flying Solomon still hanging out. Glad you guys are all still here. Cool. Alright. Alright. Okay. We are now able to continue. So, yes, this does the allocation, and so now what we want to do is we want to track down over here the right place to write that allocation code. And I suppose once we have the allocation, let me write down the code of what that does first. So we're gonna mem set it as soon as we get it. I'm gonna assume that the allocator mem sets it for me, and then I'm gonna say, oh, you know what? Before I do this, I should actually I should actually do this. Okay, so when I grab that marker, I haven't done enough yet to get to this point. What we actually want to do is more like whatever this over here does. So models, yes, and then managed object putter and workspace. And then we want to make sure, whoops, no, you get out of here. You get out of here. Do that. There we go. We want to do that. Wait, no, we don't want that. This is the one we want. So, if we have a real object here that's actually a buffer markers object, then we will do this work on the workspace that we get from object putters. Code Slasher says I am getting no sound, but then Jim says that the sound seems to be good, so hopefully we don't have an issue. Let me know if you figure something out, Code Slasher. I can also reset if something's not working. Okay. So that's more like it. We make sure we have a buffer markers, and then we do that stuff. And so what we're going to do is, in addition to all that, we also have the markers header right here. Which we get from casting out that. And then, what we can do is say, okay, so this markers header here, we want to start initializing the data object. Well, we need to ZDLL pushback onto the markers first, markers, these should be visuals first, visuals last. We want to push the new piece of data, and then we want to do markers visuals count plus equals 1. Then we want to do data markers equals the markers, and what will happen is if the markers get freed, then all of the data blobs get freed that it contains in a bulk free. We just take the first to last chain and we put it into the free section right here of the allocator. If we want to free one of these, then we can just take that pointer out of whatever list it's in, look at that pointer, we'll have a pointer to this, so we'll say here's our self, get access to our list through this, decrement that, take us out of this list, insert ourselves into this list. That's how we free one of these things. If we free one of these, we take all of these and put them here. And finally, all of this will be allocated inside of this membank here. So if we free the whole scope, we just clear the membank and set all this to 0. Now the only remaining problem is what's the point of this ID in this table? The point of that is when we create one of these things, yeah, that's why we can't clear it to 0. When we create one of these things, we're going to look and see oh, thanks Latom Boren Royal for marking me. Yeah, so the question is there any chance of supporting pop-up UI type stuff like completion lists for, you know, whatever code completion or word completion type stuff you have and documentation and stuff like that? That's going to be coming along someday. It's not on the short horizon, but we have completely customizable UI now, so this is customizable, this is all customizable stuff like this. Well, hold on, let me pull it up. There it is, like this. And so my plan is eventually to get to a point where there's no distinction between a UI mode and a buffer mode, and then you will be able to just be typing and have UI stuff that you specify for yourself pop up that's a part of the buffer wherever you wanted it. And at that point, you would be able to do what we will be able to do what you're talking about, like completion drop-down menus or something. Someday, but that's going to be like a 2019 thing after the new engine is done. Okay, so the complicated thing with this data type is we can't ever clear it because it's got this ID that is static after it's been created. And so what happens is we get back one of these things, and then we can set visuals to equal we have the workspace scope ID on the 32 high bits, ORed with the data ID in the low bits. All the rest of that will be filled in with default values whenever we allocate one of these. Not necessarily. We should make a call for that. So marker visuals fill defaults. Okay, So we grab one of these data things off of our visuals allocator. We find out what ID we have now. The only problem I have with this at this point is, yes, we have a 32-bit ID. That 32-bit ID is unique to which allocator it's in. Okay. Because what I actually kind of need is, in addition to an ID, I need like a reuse counter. And that's going to mean that what we actually need is under types. This isn't going to be marker visuals uint64. It's going to be struct marker visuals managed scope uint32 slot ID generation ID. Okay, so this is the one we use to look it up in the table, and this is the one we use to see if we have the most up-to-date version of this particular slot. Okay, take rule. The default take rule is going to be first index equals 0, take count per step equals 1, step stride in marker count equals 1, maximum number of markers will equal max I32. Alright, this priority thing, I don't fully know how I want this to work out yet. Right now I'm just type defing priority level. Somewhere. Oh, this is not in types. Okay. So the question is, how do I actually want this to work? Do I just want people to submit integers that are somewhere between negative and positive, whatever, and then sort to the highest one? Do I want to actually turn that into an enum with like specified levels? I'm not sure this is the right system, but I don't really feel like doing the right system this time. With the deadline I've set of next weekend, I feel like getting the full priority system figured out might be something I want to put off to a future build or to the next engine or something, because there's a question of how would you ever do this properly. Like, I have two different modules that I'm bringing together, and they both have their own notions about the priorities of their UI elements. But how do they merge together? I mean, how would they ever? Basically, what you would want is the person who's composing the modules to be the one to say, hey, I like it better if this stuff goes in this order. So what you would do is you would have each module say, hey, I declare which priority levels I believe in and the sorting order amongst my own priority levels. And then if you have two modules that come together, then anything that it's like we have the first module has A, B, C are its levels, and the second module has 1, 2, 3 are its modules. As long as A, B, C stay in that order and 1, 2, 3 stay in that order, it could be A, B, C, 1, 2, 3, 1, 2, 3, A, B, C. It could be A, 1, B, 2, C, 3, or A, 1, B, 2, 3, C, or whatever order follows the two sub-rules. But that's like a lot of stuff to figure out the right way to canonicalize a way of talking about merging this together, that we don't even have the rest of this idea of what a module is made concrete at all anywhere, and I'm a little nervous about trying to think about that with, like, that's a thing that we could solve in the abstract if we had the idea of a module more fully developed, which we don't have yet, and which I don't plan to do in alpha mode. So for now, we're going to do priority levels like this, and what I'll probably do is in the future we will still use an int32 to be a priority level, but they will be generated by a sort of like declarative thing that creates these priority levels on a per module basis, and then somehow converts the indices into priority numbers that are sortable in the core. Like, it'll somehow be like, we define, like a module says I have these 3 layers, and another module says I have these 3 layers, and they're all separate names, and then the person merging the module says I sort the layers in the following order. The modules have put constraints on what order they can be in, but there's still a lot of flexibility, so when you're putting your modules together, as the user who says I'm composing these, you would specify an order. The core would check that your order is legal, and then would facilitate the conversion from layer names to sort indices, but we're not doing any of that right now. There we go. Alright, time to make the allocator. So if we have something in the free list, then what we're going to do is we're going to say OK, grab that thing. Actually, that's not the way this usually ends up working. It's usually more like if it is equal to 0, we do some fill in the free list with more slots from membank. And then we grab the allocator free first. We zdll remove allocator free first, allocator free last, data. We then take data gen ID and we increment it by 1. And we also want to, that's the thing I was trying to remember, we need to free count minus equals 1. And then we can return that data. Now, how do we do this part? Fill in the free list with more slots from membank. So, what we want to do is roughly say, like, well, maybe we keep a count here of total visual count. And what we do is we say new slots equals clamp bottom. We always want to get at least 16 new slots, at least 8 new slots, maybe even. It could be quite low, I think. Yeah, we'll do 16, and then we'll take the allocators total visual count. So we'll double the total visual count every time. If 16 wasn't enough, we get another 16, and if that's not enough, we get 32, and so on. You know. The cool way to do it. Alright, let's see. What do we do? So we get the number of new slots, and then what we want to do is come over here to dynamic memory bank allocate. Perfect. Okay, that's the thing I thought it was. So, new slots memory equals dynamic memory bank allocate. We use the heap and the membank. It'll try to put the memory into the membank, and if there's no space in the membank for new slot count, then it will allocate that new space on the heap first, plus some other, it'll allocate that much space on the heap, plus some extra space. And you can see it always gets at least one 4K block. And then it'll extend the bank's heap with that new block page, that new block of memory, and then it will finally allocate out the part we need this time being successful, and return it to us. And then what we can do is say we want new slots, then we can do an iteration over all of the new slots. And what happens with each of those steps is that the slot ID becomes the allocator's slot ID counter, like so. And the new slots, we're going to memset the new slot to 0. Well, why don't we just memset all of the memory to 0, right? So we clear it out to 0, we grab our pointer and we start iterating. With each step of the iteration we fill in that slot ID, and we're going to push it onto the allocator free list. So we're going to push back onto the allocator free first, allocator free last, new slot, allocator free count plus equals, well, we don't need to do that. We can do new free count plus equals new slot count. And then we filled out that array, but we also want to, at each step, be inserting into the ID putter table. So let's go check that out real quick. Okay, insert into the U32 putter table. Here is the interesting. So the problem with this is I wanted to use the dynamic memory bank as its allocation scheme, not a heap. And I have implemented this as a heap thing. So I'm going to just grab this and implement it again right here with a dynamic memory bank. And so then all of the heap allocs can get replaced with dynamic memory bank allocs. Membank. Dynamic memory bank free. Membank putter, and then there you go. So this suggests to me that I'm not sure what I want to do about that. It's annoying because there's like so many layers of wrapping you have to do to make abstraction of this type of work. I could make a generator that just knows how to generate it, pull memory bank up to a higher level, Yeah, that would actually not be bad. Sorry, I got a little hair stuck on my keyboard. I like to keep it clean. So, moving on. Keep membank. We want to use the allocator's ID to putter table, and we want to store that slot to that slot ID to that slot into that table. Okay, so where does that leave us? When we allocate one of these visual allocs, or when we allocate one of these marker visuals, we see if the allocator is out of slots. If it is, we allocate more slots on the memory bank, and then we initialize them by clearing that memory to 0, iterating them, and at each step we put it on the free list. So there are now free slots on the free list, and we set up the ID and add that to the ID to putter table so that from now on we can find that slot via its slot ID. Then we look at the allocator's free list to grab we get the first thing off there. We remove it and decrement the counter, increment this thing's gen ID, and then we return. Okay, alright, we're getting somewhere. Now, to go along with that, we're going to want a marker visuals free, and for that all we need is the membank and the marker visuals allocator. I just realized something cool. I'll explain it some other time. Okay. All we have to do here is just zdll push back on the allocator free first, allocator free last. Sorry, we don't need the membank, we just need the allocator for visuals and the visual itself. Marker visuals data. And then whenever we do this, the other thing we want to do is the free count we add. We're also going to want to make sure we can increase the total visual count by the new slots count. Okay. I was just thinking that because I was thinking, oh, we don't change the total here, and we don't change it here. Then I was like, oh, we didn't even change it here. That's a problem. But there we go. Now we do change it there. So we have the ability to allocate and free these things, fill them with their default. The only other thing we need to be able to do is given given the allocator the slot ID and the gen ID, what you want to do is Okay, so what we need to do is look at the putter check table and see how does its lookup work. Yeah, so what we're going to have is a data putter right here, and then if we do lookup U32 putter table, we get allocator ID to putter table, slot ID. We need a void here actually. Data putter. So if that succeeds, then we can return, well, we can't quite do that yet. Data can equal 0 and, well, data can equal marker visuals data putter. And if data gen ID equals the gen ID that they're requesting, then we return the data. If any of those steps fail, we don't find the slot in the table, or we find the slot but the gen IDs are wrong, we end up returning 0, saying that thing doesn't exist. Okay, so we have allocate, fill with defaults, lookup, free. I think that's everything we're going to need. So let's get back to this. Here what we're seeing is a fill with defaults, and we're initializing, well, right there where we're initializing the visuals that we're going to return. Here we're initializing the data for that visuals block, and right there we're doing more of that. Okay. So the allocation process initializes a little bit of it. This initializes a little bit more as we put it onto the markers struct, and then we link it back to its own markers struct. We fill the rest of it with the defaults, and then we fill the return struct with the scope ID that we need to get back to this visuals allocator, the slot ID, and the gen ID. These three things together uniquely identify one marker visuals object. And then now we need to implement some of these other things, like set look. So we're going to need a get dynamic workspace call. That's going to rely on the models and the workspace ID, which we'll get out of visuals.scopeID. If the workspace does in fact exist, then we are making good progress. The next thing we want to do is grab out of that workspace the visuals allocator, marker visuals lookup. Wait, that's for later. Here we're just doing workspace visuals allocator. Then we want to do the lookup into the allocator. We're interested with the visuals.slotID, visuals.genID. And if that succeeds, it will return to us a marker visuals data pointer. If we get a data pointer, then we can set all of its look parameters. Before we do, this is very obviously going to want to get pulled out, and I say that because we have three more sets that are all going to just look the same. right up until the point where we have something that's going to be different about them, which is right when I'm checking which of the 4 blocks to set into. Up until this point, it didn't matter which of these 4 we were doing. Therefore, this is going to be the get marker visuals pointer call. It's going to take the models and the marker visuals it's going to do all that work. And so then we get a marker visuals data pointer. And then we just do our operations if the data is not 0. This can be the modus operandi of all these functions. Let's see, then we can do marker type equals type. Why don't we just name that to type though? Color to color. Text color to text color. Text style to text style, right? And all the rest of these will be very the same. The take rule, copies from the take rule. The priority, copies from the priority. Key view ID, da 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 da. Okay, so when we're getting our visual markers, now what we have to do is for each node, we're going to begin a sub iteration that goes for marker visuals data equals node visuals first. Data, and then we want in each of those to do all this work. So if the data type is invisible, we skip it. If the data, so this one we can do right here, if the node buffer ID does not equal the buffer ID we're interested in, we skip it. If the data key view ID does not equal 0 and it does not equal that, the view ID that we're currently rendering, we skip this data. marker type equals node marker type color equals node color text color. That should all come from the data. As should this. What else you got for me? Alright, what happens here? You can't tell which one it is at each given time, right? So get dynamic workspace from object. Alright, so I'm gonna just, go a little bigger with that, because why not? Then the question becomes, what's next? So we fixed all the problems. Okay, the next thing we need to do is, let's just finish these three and then get on with our lives. So, how do I destroy a marker visuals? I'm obviously going to need both of these. I'm going to want to do the get marker visuals pointer thing, but I want to get the workspace while I'm at it. So it's going to look like that. There we go. So that's how we destroy one of these. And then it will never be valid again, because the next time you allocate that slot... I just thought of something. Yeah, I need to, when I free an object, no, not that one. When I free one of these visuals, yeah, I need to set its markers to 0, and then when I'm looking one up and I get one, I need to assert, or I need to check that its markers does not equal 0. If it doesn't have a markers pointer, then it's freed right now and it's not valid, even if its gen ID does match. Okay. Now, if I do this one, what I'm doing is I'm saying go to this buffer markers. Wait, I just deleted the thing I would need. I'm going to want that and that. Okay. In this one, what we're going to do is basically the same thing to get us started. And then what we're going to do is say, okay, well, still give us that part, but not this part. What we're going to do is instead grab the count, like so. Then we're going to take a marker visuals and push an array onto the partition. And if that does not turn out to be 0, we'll do some work and return it. And then what we do is, for that work, we're going to So we fill out all of these visuals, and then we return that array if we manage to allocate it. Alright, there we go. The new API has been implemented. Before I check any of it off, I should test it. So I'm gonna check it all. But all of this stuff is in there now. Well, this is not in there and this is not in there actually. I have the ability to do these things here are all working, but the take rule and priority we haven't actually done yet. Okay. Yep, okay. Let me see if everything that we've added so far works the way it's supposed to. And then we're going to go and implement take rule and priority and see if we can exercise them and see if that's all working. What went wrong? Our arena is empty. How did that happen? Are we stuck in an infinite loop? Okay. We're obviously stuck in an infinite loop, so I need to check a few things. When we first get a marker, managed buffer markers, alloc buffer markers on buffer, there it is. So we need to clear that part out to 0, and then we need to also make sure if it's a markers type, we already are doing special stuff to remove the markers type out of the markers list. We're also going to now do special work to bulk free the markers list. So workspace. No, don't crash. What was that? Okay, that's I haven't seen. I've been working on 4coder all week and I haven't seen that. I don't know what that was. That's not a good sign. Ah, shoot, it's all gone. Alright, and again, visuals first, last, and count, saving that progress this time. Okay, when we free a managed object, in addition to everything else we have to do, we want to marker visuals free chain, a workspace visuals allocator, and then we just need to pass in all the information for the chain. So it'll be visuals first, visuals last, visuals count. Okay, now we want a free chain, and the way this will work is you pass in the allocator, you have to pass in first and last, and a count, and all you have to do is for marker visuals data first, there we go. So, this is lame. After all that, we still ended up not being able to avoid iterating the chain. Why did it fail? It failed because we still want to mark these things as freed somehow, so that we can detect that they're freed when we come to them. There's no way to implicitly mark the whole chain as free in one go. At least there's no way to do it that I'm okay with. So if you put 10 visuals onto an object, I guess it's just going to take 10 iterations to free the whole thing. I don't know what else it could do. I mean, the only other option would be that instead of storing a pointer in the visuals, we store the ID to the object, and then we look up the object in the workspace. And if the object is gone, then this thing is free, so we don't actually have to iterate it. The problem I have with that is it means when we're trying to get to the pointer, we have to do extra work. But I guess that we could store the pointer too. The pointer takes you to the thing when it's live. But when do we actually need the pointer besides right now? We don't. Okay, so what we're going to do is instead we're going to change this to this, and then we're going to say we need to be able to look this thing up, and if the object exists, then we believe in it. So how do we do an object lookup? Dynamic workspace get pointer. Okay, so I'm just going to need to hoist that up here. Actually, I'm just going to drop this one down here. This is going to become dynamic workspace get visuals pointer. Dynamic workspace. Okay, so that's a little bit different than what we had before, so we'll have to work that out. But in terms of what has to happen here now, the answer is just a chain free. Now I'm not sure if my macro system here actually has chain frees built in. No, it doesn't. Okay. This is like my worst macro system out of all the ones I've ever made, so it's my oldest one. So it's got problems, you know? Yeah, no? So let's see. This would be owner object. Owner object. And the owner object is that object right there. Okay. Now what we do is when we want to free a chain, we take if allocator free first equals 0, then allocator free first equals first, allocator free last equals last, else allocator free first next, wait, allocator free last next equals first, first prev equals free last, allocator free last equals last. Then either way, the allocator free count plus equals by the count. Now we can chain free an entire set of visuals in one go, and all of those visuals refer to the object by an ID. So if the object has stopped existing, then we will know that as soon as we see it in the free list. We will look up its object ID and go, yo, that don't exist. So the way that has to happen is down here. We are going to, okay, we've dynamic workspace get visuals pointer. So the way this works is it's all based on the workspace visuals allocator. We look up in that pointer table there. If we get a result, it goes into that data pointer, which we then cast to a data type struct, and then we check its gen ID. If the gen ID is good, then finally the last thing we do is we're going to attempt to get a pointer out of the workspace again using dynamic workspace get pointer. We use the workspace that we already have, and we use the data owner object, the low port part of that ID, and If that works, then we go, okay, success, we have a valid thing. Take a 5-minute break, be right back. Okay. Not even a minute, probably, but I don't know. Maybe a minute. Okay. So now I've added the chain free thing that I forgot to add. Now the question is, when I'm freeing a managed object, do I actually invoke this? I think we wrote that. Yeah, free chain. Yep. So we can do the free chain part, and the lookup now goes through that, so the free chain doesn't have a loop in it. Okay. Let's see if I was... There we go. Okay. So yeah, the problem, as I understand what happened there, or if I did correctly understand what happened there, my theory was that this was failing because we were in an infinite loop. It looked a lot like we were in an infinite loop. I didn't totally confirm it, but I had very strong suspicion. And so the two things that could have caused an infinite loop, and it's possible that either or both of them did, but the two things I could think of that I knew were bugs that might be causing an infinite loop were, one, I was not necessarily freeing everything properly if I ever closed a marker object, and two, I was not initializing the first and last to 0, so it was possible that somehow the last looped it around somewhere else in the chain, or it was in the garbage that was somehow readable memory. All kinds of things were possible. Okay, now... Oh, you know what? I made some changes on a different computer, and I forgot to merge them before we started. I should do that next. But it does look like everything is still working. Everything that was written before is now working through the new API. We have visuals. I can do loaded config, and that works. Okay. Let me do a quick git merge here. All right. Um, all right, I think we got lucky, and none of my changes collided with each other. Yep. Okay. Cool, cool, cool. So, we have all this new API in place. Now what we want to do is we want to make sure, and it's working, or parts of it are working, but some of it's not implemented yet. Now what I'd like to do is just take one little piece here and try and make something else work. So, if I look at my to-do list, the part of the API I haven't done yet are the take rule and the priority part. I'm going to do take rule first. So, let's take a minute and do managed object cursor and mark equals alloc buffer markers on buffer app buffer.buffer ID to throw that in the render scope for me. Then I'm going to take markers, there's going to be 2 of them, and markers.0, so these are going to be like CM markers or something like that. 0.position is going to be view.cursor position, and this will be view.mark position. And then we are going to managed object store data onto the cursor and mark 0 to C markers. There we go. So there we've just stored our marker data for the cursor position and then the mark position. And then what we want to do is leave it up to everyone who follows to add coloring options. So, get theme colors, good. This part, no, no, no. This part, yes. No, no, no. So we create 2 different visuals. The first one and the second one, they're both going to go onto the marker, cursor and mark object. The first visuals we set their look, which is still correct, and then we're going to set their take rule, which is going to look like this. Marker visuals take rule. So the take rule, the cursor comes first, and this is the cursor color. So yeah, first take count per step. So we're going to just do all of these. First index. There we go. Take rule dot take count per step. Take 1. Step stride in marker count. Take rule dot maximum number of markers, take 1. And then there's my take rule, and I set it. If I just make a couple of changes here, marker visuals type visuals, and then take rule. So there we go. Set the look. Then we grab the visuals again. This time the only difference is we set a different look and we set a different take rule. And the only difference in the take rule is that we start at index 1 and then we set that as the take rule. Okay, that's all I want to change so far. So the difference between these two is the difference between what we were doing and what we're doing now is that now we only create one of these objects, and that object works for both of these. Now we have to create 2 visuals, which we didn't used to have to do, but those visuals are lighter weight than the actual objects themselves. They're at least a little bit lighter, more lightweight. And since we can do this, we don't have to just do it here. This case can also rely on that object. This case here can rely on that object. I don't think, neither of these use that information, but this down here will be able to go from 4 objects down to 1 object and 4 visuals, which will be simpler too. So it's going to be nicer overall, the way the code shakes out with this new setup, I think. It does take extra calls now, which means extra lines to get a marker or visual set up. Takes at least 2, and then probably 1 or 2 more depending on your use case. Like if you want to change the priority off of normal, if you want to use take rules that just increase the number of lines that it takes per visual, but it is a better organization of the data itself, I think. So it's obviously not going to work because we haven't implemented the take rule, but we can do that now. So how does the take rule work? Basically, if we come in here and we look at that spot where we are iterating over, this one right here. So we're iterating over these. We've determined that we should render this, and so the time comes to iterate over the markers themselves and add them to an array of render markers. So this is the part that's going to be affected. We're going to pull out the take rule. Up here probably. Marker visuals take rule. And then the way the take rule for it works is we go, okay, take rule dot first index, 1 past last index equals clamp top. I can't get larger than count, and I have to think about this a little bit. So if we go to types.h, where's the take rule? How do I want this to look? What things do I know? I know that this is going to be I plus... You know what? I just want to do it like this. I want to do marker 1 past last equals markers plus count. Take rule dot first index. And then what we're going to do is say the stride. So we increment the marker by the stride amount. Actually, what we're going to do is we're going to increment it by the stride from last. Okay, so that's all good. The only problem left is this number here isn't actually correct. This is the end of the total, but we actually want to look at maximum number of markers to figure this out. So if we were always taking 1, this would be simple. We would just say clamp top between this and this. But it's not that simple. What I actually need to figure out is, like, I need to compute this in integer space and then do the cast a pointer. And this is like clamp top count, take last index, take 1 past last, and then what's the take 1 past last? The 1 past last take index is the thing you get when you say, well, we want this number. I see. Take rule dot maximum number of markers divided by take rule dot take count per step. So if those divide evenly, if we're taking 3 per step and there are 9, then there would be 3 steps. So I say this is the number of whole steps if we, let's see, extra in last would be this modulo this. So if we say take 3 per step and we then ask for 10, it would mean 3, 3, 3, 1. And that means that we have one extra in the last step. We don't take 2 or 3 in the last step, we take 1. So that's how many extra there are in the last step. That's the total number of whole steps rounded down. If extra and then what we do is we say if we have any extra, then we add 1 to the number of whole steps. Then our 1 past last index is the number of whole steps times the take rules stride amount plus the extra in the last. Then we say, okay, that's not quite the whole though. That's also, we need to add the take rule dot first index in there too. Now what's interesting is we could just be storing that over here. Okay. Now if we come over here and we look for set take rule, then what we'll do is we'll say compute all that. So the number of whole steps we want to take, the amount of extra in the last step, the new amount of whole steps, and then the 1 past last take index goes right into data. And so that tells us exactly which index to stop on if we don't run to the end of the buffer markers first. Markers 1 past last, and so then we clamp to the larger of the 2 of these, or to the smaller of the 2 of these. We clamp to the top, so that means whichever one of these, if this one overflows past this point, we use this one, right? To count is clamping this from the top, is the way to think about it. And then marker equals markers, stride size from last, yes. Now which of the take rule are we actually using? We have first index, step stride in marker count, take count per step, and take count per step. So we actually don't want all of them, we just want those 3. Fair enough. First index, first index, first index. Now, if we replace first index with nothing, then that would be a mistake, because we meant to replace it with z. And then we can do z is take count per step, and then there's step stride in marker count. first index. Some of these get used just the once, so I'm going to not actually pull them out at all. Step stride. Stride size from last. That could actually be pre-computed too. But I don't think it should be, now that I look at that. We can still do that there. Okay, so there's the one for that. Now, this is where it gets a little weird. How do we do the take rule for ranges? My thinking on this has been the first index gives me the first index is aligned off the range. It doesn't have to be on an even number, basically. Take count per step. What we could do is just say the take count per step is expected to be even. In the sense that it might be odd the take count per step might be 3 or something, but we are going to skip the third one in that case. Alternatively, it could mean that a 1 in that position means actually take 2, but if we do that, then all of the indexing stuff gets off. It could also mean that it means take 3, and then you take 2, and then the next one, the third one in this set, and the first in the next set are a pair. I feel like that's the best option, because that lets you express that if that's ever something you want for some reason. Like, to spread out your ranges so that you don't have to put pairs next to each other. So that's what we're going to do. Okay, and then what we're going to do is use literally the exact same iteration rule. Same iteration rule either way. We start iterating it, and at each step what we do is we say then every time we get 2, we emit them the way we have always done from here. So the way this has to look is marker pair 0 position, marker pair 1 position, marker pair J position. Really, we don't need marker pairs. What we need is just position pairs. And so this would look like this. This removes an extra dereference. Okay. So now what we're doing is we're iterating in by the exact same rule, and every time we see 2, we like buffer the first one. The second one we see, we emit that as a range. We see the next one, we buffer it. We see a second one, we put it in the buffer and emit that range. And we keep doing that, which means that our ranges no longer have to be right next to each other. They could be spread out. Like I could have 1, 2, 3, 4 numbers, and then 1, 2, 3, 4 numbers, and those are supposed to be 4 ranges that I'm striding out that way because that's the way the memory wants to work, rather than it only having one memory layout that it accepts. And so this take rule lets me express a lot of different ways of doing like things like that. So now a range can be expressed as, I want you to do like just in order, or it can be like take 2 out of every 4. It can be take 1 and then skip and jump 2, and then like take the first one, 2 over, take 1, take 2 over, take 1, and so on. There's all kinds of options for how the take rule can help you like swizzle your pairs for the range. And this up here didn't really have a pairing problem, but it also lets us do all that swizzle work now. So let's see if that compiles. Oops, wrong naming scheme. Alright, there we go. So let's see if I still have a cursor and mark the way I should. Yeah. Okay, so that's working pretty well. If I mess around with this at all, what if I open up the auto indenter, for instance, and I'm not seeing the scope highlighter anymore, which is weird. Did I turn that off? I may have. I can't remember. I don't think I did. Cursor and mark definitely still work the same way as ever. That doesn't work. I wonder if the default take rule has a problem. Okay, well, let's take a look. I feel like there must be something wrong with the take rule for things that use the default take rule. So let's close this panel and switch this into find loaded config file. Okay, so it should be able to find that. Let's go to forward view. Yeah, we want to look at get visual markers and show me what happens in here. Okay, so we do visit here, and let me take a look at what all these say. Take count per step, step stride and marker count, stride size from last. So this then goes, are we past last? What is 1 past last index equal to? 1 past last index is equal to 0. Our count is 2, but our data... I know what happened. We need to go to dynamic variables default. Default. Okay, that's why I couldn't find it. There we go. Okay, now I have the line highlight. Let me pull up indent code again. Close this panel over here. Hey, there we go. Now that's working again. Okay, so it's all working. And now we need to, let's see, what else we got going on? So I think the first thing I want to do is I want to have all of these use the new take rule stuff. Like this right here would benefit a lot from being able to go, here's the take rule. Don't bother with this. Don't bother with this. Okay, so we create new visuals on cursor and mark, and then we set the look of those visuals like so, and then we're going to set the take rule on these visuals to be take the first marker only. Here, down here, you can see we're pushing 2 markers down. That's because this does the whole range. So we're now actually saving memory a little bit here, because all of the stuff we were going to have to submit for visuals, we were still submitting anyway. So whether or not we were submitting it or are submitting it, we're submitting the same amount of stuff basically. But we were submitting 2 different objects as well. Before we basically had all the data it takes to describe a visual plus all the data it takes to describe an object twice, and then inside those 2 objects we had the cursor and then the cursor and the mark. So the cursor was duplicated in this one too. Now we have one object with cursor and mark, and then we have 2 visuals, one visual and possibly the second one, or up here just 2 visual objects. Much happier about this. So let's see. Ooh, the only problem is this needs to be in sorted order. I'm gonna nix that rule and say that rule's no good. I don't like that. I'm not really sure why I thought that was a good rule when I first made it. So now it doesn't matter what order they're in. I don't have to create that object, and we create the visuals. Should throw these visuals well, we just use that one again. We put it on cursor and mark. Set that. We still want to set the take rule, only now the take rule is going to look like this. It's going to have the same first index that it always had, but it's going to have maximum number of markers up to 2. So now it'll take both of them to make its range. Alright, now what? This one here is creating an object for the cursor position. That's not necessary at all. We'll just create a visual on the cursor and mark again, and we'll set the look the same way, and then we will set the take rule. And the take rule is just take the cursor. So I'm starting to detect a common theme, which is I want to make maybe wrappers for common take rules that are like take a contiguous range, and then maybe like other ones might come up or something, I don't know. But it's obvious that a lot of times there's little basic ones that are like just take index 0 for a count of 1, or take index 0 for a count of 2, or take index 1 for a count of 1. Like, I could use those helpers. So maybe revisit that. Maybe revisit that concept before this ships. These ones are a little different. They actually involve, this one here actually involves finding a new range, and it's unique, so it makes sense for it to be its own object with a visual that doesn't have a non-default take rule. But this one could change quite a bit. First, I'm going to take a look at, make sure that the line highlighter still works as expected. Yep, that looks good. Okay. Now what I want to do is I want to simplify this code. So let me read out how it actually works right now, and then think about how to reorganize it with take rules. So we start by allocating, or like finding a range of, or an array of ranges where each range marks the parent. The first one you see marks the immediate parent of the cursor. The next one is the parent of that, and the parent of that, until you can't get another parent scope because you're at the top level. So it's basically an array of the parent scopes of the current position of the cursor. We get the count of that range, array of ranges, and then it breaks it down into buckets like this: bucket count and leftover count. Bucket count is, it's talking about, when it says bucket count, how many things there are in each bucket, and this is how many there are left over after dividing things into buckets. None of that is necessary anymore. What we just want to do is make sure that the last thing in the array gets red always, and like gets the gets the 0th index, I should say, and that the second to the last thing always gets this spot, and the third to last thing gets this, fourth to last gets this, and then fifth back to here, right? We want it to align that way so that the thing at the top always starts the color like iteration and then iterate backwards down the array so that a scope's color doesn't appear to change as you move to its parent or something. So all we have to do to achieve that, I don't think we need any of this. What we are going to need is a new managed object. We'll call it O, alloc buffer markers on buffer, app buffer.bufferid, marker count, render scope. The marker count is just the count times 2. We're also going to want an array of markers that looks like that. Push an array onto our scratch of markers, marker count of them. And then what we're going to do is we're just going to iterate the entire range or array of ranges we just got. Okay, and just like that we have our buffer markers. We then want to store data onto it. We're going to store all of those, and then we just have to do our 4 visualizer or visuals. The first visual that we just want to figure out the first index, right? First color index equals, and so basically the first color index would be 0 if we had 1 element, 2 or 1 if we had 2 elements, 2 if we had 3 elements, and 3 if we had 4 elements, and then back to, if we had 5 elements, it'd go back to 0. So what's the pattern? The first index grows by 1 each time the array size grows, so it's just a positive correlation. We do the, okay, it's -1 modulo 4. So we want to do count -1. This should all be if count was greater than 0, actually. Count -1 modulo the number of the color count. There it is. And that gives us our first color index. And then what we want to do is a loop that's like there we go. So So that'll get us a loop over the modulo range starting from wherever we ask it to start. And then while we're at it, we're also going to want... Wait, why don't we do this in an easier way? Okay, so now we can do marker visuals equals create marker visuals. We want to put those onto the object we just created earlier. Now these visuals are going to have a particular look. That look will be visuals buffer markers type character blocks. We're going to use enclosure colors color index, symbolic color default 0, and then we're going to make a marker visuals take rule, and we're going to set the take rule. And the take rule is going to be that the first index equals I times 2. The take rule is going to be that we take count per step is 2. We take 2 at a time, and then we step stride in marker count 8 times. Finally, we'll set the maximum number of markers to largest thing we can set it to. So in total what this will do is there's only one mistake. I need the color index to decrease, not increase. Okay, so the only other thing we could do to make this even better is to say all of this doesn't appear to be changing every time we go through the loop, so why is it in the loop? Why don't we instead pull it up here and just change that part every step through the loop, the first index. Everything always grabs 2 and then jumps 8 ahead, grabs 2 there, jumps 8 ahead, grabs 2, 8, jumps 8 ahead. It's just where does it start that grab 2 process from, and that's what's decided right here. So we make up to 4 possible visuals. Yeah, I think this works. There we go. Okay, so that's not working, I would say. Okay, so a couple of observations here. It doesn't put the thing on the bottom, so it only takes one before it gives up. It doesn't... If I'm here, it doesn't take this one, it also doesn't take those. So we can be pretty sure that what's failing here is it's only taking one and then stopping. The total number should be 2, 4, 6, 8, 10 of these. Okay. Let's take a peek at... Let's take a peek at that. We're gonna want a breakpoint there when the time comes. Now I want to see, do we have the count of 10? There it is. Okay. So this is one of the 4 different take rules. What is the take rule here? First index is 0. Okay. Take count per step. Step, stride, and marker count. Stride size from last. Okay. Count is 10, 1 past last. Index is only a 1. So how did that end up being a 1? That's what we need to find out. That gets set in the API implementation. I want to see it. Okay. So show me the take rule. Actually, before you even show me that, why don't we just go down... I mean, we know what code we're running. We're running the render color. It's the only code that even calls the take rule stuff, so... okay, that's fine. That's not the one we wanted. Okay, now the take rule here says first index 0, take count per step 2, maximum number. Okay, great. First index 0, whole steps. Oh, I see. No, I don't see. 1 past last index, extra in last, plus 1. 8. Okay, so it's going to get too big. Okay, so what I want to do is I want to have a special constant that you can set that just means no max, and that's going to be 0. And so in the API implementation, if we see that data take rule dot maximum number of markers does not equal 0, we'll do this. Otherwise, we'll say this is max I32. Boop. There we go. Alright, I'm going to take a 10-minute break. I'm going to shut the stream down for this one, and we'll be back with more in not too long. See you in a bit.